session. So as we continued the further continuity for all the beginning coders or any kind of professionals who have to understand the DSA, they have to basically be good at first linear search, and then we have to understand a lot of things in the binary search. So let me talk about linear search. So firstly, if we have an array 5, 3, 7, 1, 9, and if your target is 1, so how do we do linear search? Everyone knows it. So I did not tell you that. So we will try to compare with this data. We'll route from this index 1, 2, 3. We'll try to compare it. So we'll check whether I'll find 1. So target is 1, right? So I'll try to find out that 1 where it's present. So mostly in the case of linear search, we try to compare that target. So that is in this index 5. Step 1 is you compare this AR of 0 is 5. So then you compare this with 1, and then you try to compare step 3. This value is index is 3. Then you compare. But you will meet at this index value and you will be able to say match, right? Mostly this is what we do in the linear search. So let me go to the code base of linear search to all the coders, my link coders. So this is how you write a linear search code. So your linear search code is you traverse your basic thing is you have a list which has 5 elements. You have a target is 30. You pass this list and you pass this 30. You will iterate with an index, okay? And you check in that index whether the target is present. Suppose your index is something and you check this target 30. If that present, it will be finding it. So that is very simple to run through this code here. That is how we run with a linear search. Okay, you found that 30 at index 2. Okay, that's how it works, linear search. Now the question is, there is an important aspect I will be taking after this. Okay, so linear search working, everybody knows how to compare the target with each value in this array. That is the 0th index, first index, second index, then the third index, right? This is what happens. Okay, so now the question is, give me one, excuse me guys. So now what I'm going to do is I'm going to focus on linear search. That's done. So next we're going to talk about merge sorting. So what is merge sorting? It is on the process of divide and conquer algorithm. It means we divide the array into half recursively and sort each value, sort each of the values, and then we merge the sorted offs. Okay, but let's say this is how a merge sort works. So you have a list of values. Okay, you will have a list of values here. So that is something like this. You are going to split this into divide into 2 of this array, and then you're going to do recursively. So recursion is going to be the part of the role to split this things here. Okay, but now before I start off with this merge sort, so let me just run through some code for you. Okay, so mostly whenever you're working with a merge sort, so I told you, right, as I told you in the starting of this session only, for someone who's going to start off this lead code problems now and solve of it, so I can tell you a kind of this for you is that you have to understand how to do memory accessing. So that this column is going to access the first half of your list. This is going to access from the next half of your list, right? So that is from the next half of the last half of it will gonna access it. So this merge sort is gonna traverse, you call this aim recursive functions and pass this list values. Okay, but here they are actually having another list to check the value, compare the elements from them, and then add it to this list. That is what they are trying to do here. Okay, so you can just see this code sample. So what I have done is I can show you here. This is how you have a list of values. When I pass this list, it will come here. Okay, and you will take this, check the length of this list is less than 1. No, it's going to take the middle value. From this middle index, it's going to call the same function recursively. And until the elements are, it's going to be there. And it's going to take that value. And finally, when at the last value, it is going to return this. Now the question is, I know everyone will say, Venkatesh, I know how to work merge sort. It's very easy to write a business logic. But now the question is, all the users have to ask yourself, Can you explain me recursion here, Venkatesh? So I want to understand how the recursion works. We understood the sorting part, but can you tell how recursion works? Can anyone tell me how a basic recursion works in your Python? Okay, so I'll ask you a simple recursion problem here. So that recursion is the main concept that we have to understand. So before I take an example of recursion, let me show you one example. Then I can, function call, that's super. But let me ask you some things what's happened here. So let's say I'll say here merge sort. So this will take a list actually. So let's say you take list, okay? Inside this, first of all, I'll call this merge sort by passing some elements 1, 2, 3, 4. If I call this function with a list of 1, 2, 3, 4, it'll come here. This inside this, if I write, I'll check here if of length of your ERR, if it should be, let's say I'll write down it's greater than 1, or I'll say length of the list is, I would write a condition if the length of list should be greater than 1. Okay. If it should be greater than 1, if it is less than 1, let me write a return -1. Okay. If not, I am passing a list of this guy. So in this merge sort, what should I pass, guys? Anyone tell me? I'll call like this. I'll call this merge sort one time. I'll call this merge sort second time. So what should I do if I'm passing a simple list? Anyone in the audience here? What should I do here? If I do, what happens here? Hello? Any? So any question? Anyone who wants to answer, guys, here? Hello? Any basics, guys? It's a basic recursion, but what is that we have to write down a basic thing? What we are supposed to do here? Just a basic understanding. No need to take any complicated example. Just take a basic. I have a simple list 1, 2, 3, 4. Maybe it's ordered already. So maybe I'll pass 5 to 1, 4. Okay, I'm passing this thing. So inside this, what should I do? If I am creating a list and I'm passing this thing, what should I do here?
Need to pass a list.
Okay, I have passed this list. So I have passed this list. ERR is there, and inside this, what I'm supposed to do?
Again, we have to pass a.
Okay, again I have to pass a list. Okay, now let's say I'll pass here. I'll take something here left. I'll take something here right. Okay, so let me call here something here. So should I, if I am going to call here two aspects. One is 1 second. If I am doing here left and here I'm writing it as right. Okay. Now what value should I pass here? If I write ERR of colon mid, okay, and I'll write down here error of mid, the other side of the values. Okay, and now, so if I write down what is the value of mid, means maybe I'll find out here mid is equal to, maybe I'll write down the length of the ERR. Okay, and that is divided by 2. So now if I am passing this value and I'll assign it to the left and right. Okay, but I'm trying to call a function which is the same function. Okay, which I'm trying to call the same function. Okay, now what should I do here? If I am trying to call the same function, so can anyone tell me how this code works? Suppose I'll pass here merge of, I'll return the same, I'll try to return again the same thing. Inside this, I'll pass this left and right. Now the question is, nobody is going to ask you the basic merge sort, but they're going to ask you the understanding of the merge sort. So I'm sure many of you here knows it very well. So I'll take here something, a return value, and then I'm going to print this. So now this is how I will just write here. 1 second. What is this? I have to specify is I have to specify here. Yeah, I can, instead of returning this, I can return directly this. Okay, I'll return directly this a list which has left and right. Okay, fine. Okay, and now come on, guys. So I know everyone are here good coders, but let's ask this. how many times, first question is, how many times this function call happens? This is an interesting question. How many times this function call happens? Hello? How many times this function call is going to happen, and how many times this function call is happening? Each of them 2. Okay. Okay. So if now the question is, how many stacks are going to be created? Number of stacks. So number of stacks are getting created. How many stacks are going to get created? Anyone here? Any smiling coders? Okay, we see 4. Oh, good. But I think someone, okay, now let's see. I'll print here. Okay. I'll print here as stacks. And you can see number of times the stack has to come. It's going to come printed. Okay. Let me run this Python file. 1 second. What is it? Okay. So it's giving me recursion because it's going a very in-depth recursion. Okay. It's going some infinite there. Because my code tends to go in that very recursive way, right? Now, what should I do here is I'll try to put some kind of, okay, because I'm trying to pass this value only every time and there's no proper conditions for me, right? So what should I do here in this example? Suppose if I try to pass the same thing, okay, I'll do one thing. Otherwise, what I'll do is I'll try to, okay, in this example, whatever I've tried to do, I've tried to call the same guy again. So where is my condition? My condition is going to again do a mid. So what I can do is I can add one condition here. What is the condition we can do here, guys? We can check if at any place, any time, if mid value is reaching 2, if it is 2 divide something, then you get, if it is, I mean, if that its get value is 0. Okay, so let's say if this value is 0, then I'll print end of recursion. And I'll say here return. Okay, and let's now run this code. So do you see this now? What happened there? The first thing a programmer should understand whenever you are working with my, I mean, I'm making everybody hope loving it, because in interview, the interviewers also will try to ask you the focus not on the pattern. Mostly, someone has to be very clean about understanding the working of the recursion or working of the background, what's happening, how the stacks are created, what's happening. Those are the important critical learning when you are doing it in any sorting or searching technique. So mainly you can see now, for example, I'll comment out this. What is this? I'll comment out this code. Now someone was telling how many stacks you are gonna create. Let me pass it as none here. The second one I'll pass none. So let's see now. I'll run through this guy. So if you see this code, so what's happening if you are coming to this guy? So what's the output is coming? 2 stacks, and it's returning you a list with none and 2 times. Correct? Now can anyone see that? So it's, if you call this function method, it'll come here. So length of your array is not less than 1. Fine. So you will find out the length of the array, that is divided by 2. That is, you will get 2 off of this guy. So if you see there, you can print the value of mid there. Guys, I'm going little in depth. Maybe if you sound it, it's interesting for you. Then I'll find out that what is the length of your, what is the value of your mid there. So you can see in the first case, mid is 2, definitely. The second time when you call, mid is going to be 1. The third time you're going to call, mid is 0. If mid is 0, that time recursion ends. That was your return means what? It will end. So how many stacks was created? If you ask me here, totally how many times? This is 1, 2, and even for the mid of 0, and there's 3. So totally how many stacks was created? You can say 3 stacks were created in this example, right? And then finally, what is the value of left? Left has got, because nothing, it's you are none of that's, even this code or this, and none of the conditions are matching. If it is matching the none value or something, then it's end of the recursion. So left is having none only. That's why it's returning you always none and none and none. It's returning you that list. Correct. Now the question is, did we understood the recursion part of working now, all of you? And in the recursion, what is very important? Anyone, any smiling coder? What is very important in the
Random style.
uh-huh. Sorry? In recursion, what is very important? Hello.
Ending condition.
Exactly. Thanks for that. Handling condition. So when you are looking at a real-time scenarios, the organizations or any kind of people, when you are trying to write a basic logic, they will have a condition checking. They'll do condition checking and they'll ask you how does this what's happening behind the scenes and how this is actually working. So they'll deeply focus on this aspect of it. Okay. So that is the whole idea about taking this example. Now, one more question is, I will go a little bit deeper here. I hope everybody is gonna smile throughout it because I want you to do this example with the other way. Okay. So what I want to do is now, so everyone understood that this is the way we're gonna deal now. So in this now, we understood how a MedSart works now. So this means that is how MedSart is going to divide them and then do recursively and then handle this, take this data into multiple recursions, right? Now the question is, there's an important aspect for every coder to understand here, okay? Just tell me, your program is going to efficiently run with a normal function call or recursive function call, which is going to work. Let's say this was a question asked not by me. It's, let's say, I'll tell you the differences. Okay, I have a function fun1. Let me just show you an example. I have a function name called ice cream. Okay, just an example for that. Okay, I will write a function name called as something called burger. Okay, suppose if I want to give you an example, just try to understand. If I write inside this function, if I try to write I in maybe I write I in range of 0 to 4. Okay, and trying to call this ice cream function, I'll try to call this mostly 4 times. Okay, and I'll be passing this value and I'll print here, okay, number of times. Okay, so now if you print this, so this approach is good, or instead of this approach, writing this approach is good. Def burgers. Inside this, I'll try to call the same burgers. So here I'll try to call the same burger, but when you're calling burger, so I'll write a value of 5. So if I'm passing here a variable I, and I'll be passing like this, I plus I minus 1, and I'll write a condition of if I is equal to 0, so stop, that is stop this return means recursion stop. Now tell me which approach of coding is perfect. Now I know you will ask this question, but you can think behind this. Which is better? Which is better? And this was not my question. This was a perfect Google question. That's why I'm trying to ask you this question. Which is better?
Better
And
in compare. So which comparison, like for which two option you are comparing?
Now I'm comparing. This is the, okay. Let's say this is one approach of function.
Okay, another one is for loop, right?
Yeah, for loop one, yes.
So for loop is anyhow better. Reason behind recursion, it have method stacks, right? So that takes additional memory.
Okay. Okay. So thanks for answering. I think I missed your name. So your name, please. Sorry. When you
Sorry, my name is Himansh.
Okay, thank you, Himansh. Thank you for this. Any other people would answer me this? Which was the perfect one? Approach 1 or approach 2? Any smiling coder who wants to answer? Approach 2. Okay. Some are telling approach 2 is perfect. Anyone is telling approach 1. Okay.
In terms of coding, it's gonna be approach 1 is clear.
Okay.
Reason behind coding is pretty simple with recursion.
Okay. Coding is yes. So okay. So super. Now I will give you an, just give you an answer that is going to be more of helpful for you, and which scenarios you do and what is the use cases of it. So it's all, we suppose if we write like this, what happens is, careful listen. It is actually what's happening is, in case of this case, your burger function will borrow some stack. Okay. So it will borrow some stack. So 1 second. It will consume some stack. Okay, when you loop it and iterate it, what will happen is, in this case, what happened? The stack gets reused. Remember, this is a very important Google interview question. Here, what will happen is stack gets reused. How? Please understand this, all of you. First, if I consume some stack of, let's say, I consume 8 MB, okay, stack for this function burger, it will come to this loop. It will call the ice cream function. So ice cream function will take one, let's say it will take a stack size of 8 MB. It will allocate 8 MB stack, let's say, for the first time. When you call, it will come here and print this value. And what happens is, after this, the function dies. Correct? When the function dies, what will happen is that stack is reusable. Which is reusable? Stack is reusable. So what will happen in this case? Once you end this function, the same 8 MB is again reusable. When you next time loop it, again the same 8 MB will be given for stack. Next time also stack 2 also will reuse same 8 MB. So in this case, what is happening is memory reusability is happening. Remember this, which is very important for a coder to understand deeper way. I hope everybody is smiling. Coming to the next part of your code, that is your approach 1. In this case, what happening is memory reusability is not happening. So all the stacks are still allocated. So keep that in your mind. If you call the 5, it will come to I. It will first stack is consumed. Stack 1, let's say 8 MB. It was allocated 8 MB, let's assume. It will have variable A, store, it's not 0. It will call. So what will happen? Stack 2 is again allocated 8 MB. Again, stack 3 is again allocated 8 MB. In this case, what happens? Stacks are not reused. Please remember this. Stacks are not reusable. Okay. And this is what behind the scenes we have to understand. When it is not reusable, we keep allocating it. And at the last time, the last in FIFO, right? At that time, it will get deallocated. And this is what the fact that when interviewer or any kind of bigger organizations ask you, they will ask you to justify your approach in this question. Any doubts in this question, on this question, guys? Any questions? Ajay, Anji, Balaji, Bhuvan, Chanti, any questions? Divakar, Hari Krishna, Imansh, yeah, Kiran, any questions? Ishan, yeah, Pratik, Sahana, any questions?
So in the first approach, you mean to say stack gets increased for every iteration?
Yes, it stacks gets not reusable, but it keeps allocating more and more. Yes.
More and more. Okay.
Yes, it's allocating more and more. Yes. So you need to have a justification. It's not about which is better and what is that. So it is it's your terms. Generally in recursion, we do not use in our business logic. We use in business logic, we don't use recursion because it is not reusing stack. But in your real problems or lead codes or whatever you do, you use their recursion because to sort it. I'm not saying not use, don't take in that way. Some business problems, they tend to use it. Recursions are widely implemented in some real-time use cases. That is there. That is tend to be implementation. But it depends nearly on your requirements. Okay.
I have a follow-up question.
Yes.
This is true in case of when we have limited data, right? So we are now tackling the